Okay. Exponent properties.
You edit the videos?
I don't edit the videos.
You can hear everybody in the background. Like,
I ain't got time for that.
I'm going to hear myself.
Okay, let's start with some warm-ups that I think you know, but if you don't know, it's okay. This is more about both of us just finding out what you know and what you don't know. So if you don't know these, okay, I think you'll know some of them. I hope you'll know some of them. X squared times x cubed. Don't call them out loud. X squared cubed. X to the 7th over x to the 5th. X to the 5th over x to the 7th. And x to the 0. We don't know what x is, so you're just going to simplify as best you can in terms of x. So x squared times x cubed, what's that going to equal? X to the 5. And then, so what's the shortcut if we don't want to write out a bunch of x's every time? You just add the exponents. X squared cubed, well, let's back up a second. Cubed means we multiply the thing 3 times. So this means x squared times x squared times x squared. So that's 6 x's. X to the 6. So what was the shortcut if we don't want to write this stuff out every time? Yeah, multiply. Power to a power, we multiply. Number 3. Oh, I should have picked this number smaller than 7, so I don't have to write out 7 x's. And then 5 x's. So how many of the x's will cancel?
X2.
Well, careful. Answer. 5 of them cancel.
You leave 2, and it's x times x, so x squared.
That's x squared. But I don't want to do that every time. That's kind of ridiculous. What's the shortcut? Subtract. And then, now spare me the writing it all out. Something really similar happens with number 4. Yeah, 5 cancel in the top, 5 cancel in the bottom, and it leaves an x squared in the bottom. Now, what's the shortcut on that one? I guess it's similar. We still subtract, but you can subtract and put it where the larger one was. So some of you don't ever deal with negative numbers because you always just do the bigger number minus the smaller number, regardless of what's going on. Here, that's justified as long as you put it in wherever the bigger one was. So 7 minus 5 is 2, but there were more in the bottom, so x squared in the denominator. A few of you wrote, like you followed the pattern of 5 minus 7 is negative 2, and you wrote x to the negative 2. That's correct. We just prefer to not have negative exponents. So it's not wrong, it's just not finished.
So is that x to the 1/2, or is that 1? Like, how would you say it?
1 divided by x squared.
This is either 1 over x squared or x to the negative 2. Because the negative is what flips it over. And then this one you just have to know. What's x to the 0? 1. Some of you are like, I've got some, missed some. But that's, I mean, there's more to come today. Like that's it in terms of concepts. But we're going to start piling these things together.
How is that 1?
That's almost just by like definition. Anything to the 0 power is 1. So yeah, the others you can figure out. That one,
Why though? He was like
I don't know that there's a good explanation. I think that one's just defined to be 1. Anything to the 0 power is 1. Makes lots of other things work.
It'd be like a model demonstration though. You multiply like x. I don't know. Yeah, I guess you can't really. There's no models in there.
Like for this one? Yeah. Like the others you can sort of model and figure out. This one there's not really a model to figure out. That's right. There's not much you can do. Okay, let's do some generic rules here and keep practicing with these.
Yes.
So x to the m times x to the n, what would we do? Would you rule an example here?
X. M.
X to the what?
M.
M plus n, right? Because we're going to add, this matches number 1, we're going to add those exponents. So m plus n. So let's pick some where we would not want to write them all out. X to the 5th times x to the 11th. I mean, I could write them all out. And if I did, how many x's would I have? 16. So we like the shortcut rather than the long way around here.
Yeah.
X to the m over x to the n. What do we do with those exponents?
X.
M minus n. So let's pick some numbers that are really big so that we wouldn't really want to. I don't really want to write out 25 x's and then 5 x's and then cancel and see how many are left.
X20.
I'd rather just look at that and do 25 minus 5 and get 20. Here's one that'll mess people up. X cubed over x to the 9th. X cubed over x to the 9th.
1 over x. X.
1 over x to the 6th. 3 of them in the top, 9 of them in the bottom. So 3 of them cancel, and that leaves 6 of them in the bottom. Some people try to do too much. They're like, oh, 3 over 9, that reduces. Like, I guess it does, but that's not 3 over 9. That's x cubed over x to the 9th. Right? X to the m to the n. I should pick different letters than m and n. They sound alike. X to the m raised to the n. What do I do with those numbers? Multiply them. So that's x to the mn. So if I have x to the 4th squared, what does that become? X to the 8th. The mistake people make is they're like, oh, 4 squared, that's 16. Oh yeah, 4 squared is 16. But that's not what's going on here. Power to a power we multiply, so that's x to the 8th. And then lastly, what does a negative exponent do? 1 over. It flips it to the other side. If it's in the top, it flips to the bottom. If it's in the bottom, it flips to the top. So 1 over x to the m. So if I have x to the negative 6, that's another way to say x to the negative 6. 1 over x to the 6th. Now what starts to mess people up is if we have 2x to the negative 3.
Wouldn't that just be 2x to 1 over 2 over x to the
times
2 to the 3rd.
Okay, so here's the confusion. Everybody knows that x cubed goes to the denominator because that's got the negative exponent. Got it. Where's the 2 go, though? Stays in the top.
Yeah.
It doesn't have an exponent on it, so it doesn't go anywhere. So that's 2 over x cubed.
What do you say?
Question?
What if it was a negative 2? Would it still negative 2?
Yeah, if that was negative, it would still just be negative. Some more along those lines. How about 1 over 4x to the negative 5? 1 over 4x to the negative 5. Where does the 4 go?
It does.
Nowhere. Where does x to the 5 go? To the top. So negative exponent flips, but if it doesn't have the negative exponent, Don't send it anywhere. It stays where it is.
As a negative exponent, you send it to the other side.
Correct. If it has a negative exponent, you can just move it to the other side of the fraction bar. Up, down, whichever. Move it to the other side. Okay, let's start mixing up some rules here. So let's go 2x to the negative 2 over x to the 4th. So I have to combine rules here. What would you do first on this one? Like where's... Okay. Already, there's always, not always, there's frequently going to be more than one way to get there. And Brett and Andre are describing two different ways to get there on this problem. So I was going to work it Andre's way, and then we'll hear Brett's way and see if we get the same thing. So Andre, what were you saying?
Flip like the x negative 2. Yeah.
Okay. So Andre says move that x to the negative 2 to the bottom. Let's keep on that thought process here. So yes, that x to the negative 2 can go to the denominator. Now what do I do with x to the 4th and x squared that are both in the bottom? Add them. So how many do I have? Okay. That's good. That's our answer. Brett, what were you going to say?
Subtract 4 from negative 2.
Okay.
And then I put it to the bottom.
So Brett's used to thinking, well, we do the top one minus the bottom one. Negative 2 minus 4 is negative 6. And then what do we do with x to the negative 6? Over to the bottom. So two different paths.
Kind of the same thing though. You're just kind of combining one to be negative and then you're combining one to be positive.
There's a whole lot of this going on today, where you're going to pick one thing, your friend's going to pick something else, and you're like, oh, is that different? And mess with me right. It's like, well, they're not really. I mean, we kind of wrote it different, but it was still combining the 2 and the 4 and landing it in the denominator. So when you're either looking at my work or asking me for help or checking with each other, like, be careful, there's different routes to take. And it gets kind of frustrating because I'll ask in a moment what you want to do and there'll be 3 different answers. And that's okay, as long as you're careful. Okay, let's flip to the back. Let's do some more examples. Let's see how much we can combine into one problem here. No, don't look at the worksheet yet. It looks terrible. Should have held off on even showing you the worksheet.
Yeah.
All right, let's do this one. This is maybe on par with the worksheet, maybe not quite as bad as the worksheet. 3a squared times b, and then in the bottom, a cubed b squared cubed. I don't want to say it doesn't, but there are different ways to go. What will you tell me? What do you think we should do first on this one?
Add the ones in the...
Yeah, so that was a good go, but they're nothing the same. But I can square both of the things inside the parentheses. So 3 squared is 9. What about a squared squared? A to the 4th. And then b's, nothing I can do with that. And then in the bottom,
Well, you can do
a to the 9th and b to the 6th. And now I can look and see who can reduce here. So can't do anything with the 9. He's kind of just stuck there. What about the a's?
A,
it would just be
9
9
over-
B at the top.
9 over A5.
A5 in the bottom, because there's 4 in the top, 9 in the bottom.
And then
B stays at the
B6.
top.
9 minus 4 is 5, so that's a to the 5th.
B5.
And then the b's, there's 1 in the top and 6 in the bottom. So that means we're left with 5 in the denominator. It's not that any one particular step is hard, it's just that there was like 4 steps. I compared it to Like when you first learn how to add and we ask you for 2 plus 3, you're like 5, this is easy. But then later you had to do 2 plus 3 plus 4 plus 8. And you're like, oh, that's a lot, but the concept is the same. You're still just adding numbers. Same thing here. Like, the concept isn't hard, but there's more steps in there. Let's try one more crazy one, and then we'll talk about the worksheet.
Take count test.
X to the 0, y squared, all to the negative 3.
Nothing from that.
X to the negative 2, y, all to the negative 2. Well, yes, we're going to simplify, but when you say simplify, what do you want to do first? Be specific. Okay. So let's, you know what, before we even do that, what's x to the 0 equal to? 1. So I don't really have to worry about that guy. So y to the negative 6. Carson?
Never mind. I mean, actually,
Go ahead. You're probably going to suggest a different way to do it. That's right.
so I was going to ask if x to the 0 is 1, why don't we just keep it out because it's still there?
Why do we...
If x to the 0 is 1, why do we just discard it because it's still there?
It is still there, but 1 raised to anything is still going to be 1.
Okay.
So when you see something to the 0, you can, I don't want to say discard it, because it is still there, but multiplying by 1 doesn't change anything.
Sir, wait, but when you're trying to break the parentheses, wouldn't be that times, well, negative 3.
So like 1 to the negative 3?
Yeah.
Okay. So what does that mean we do with the 1? Flip it over.
Oh.
And what's 1 cubed? 1 times 1 times 1 is 1, and 1 divided by 1 is 1. So that's a lot of steps to show that 1 to the negative 3 is still just 1. All right, in the bottom, x to the, whoa, wait, almost messed that up. X to the
6.
4, and y to the negative 2. Okay, so my x's are fine. And probably wisest to show the step of putting the y's in the right spot. Right? Now, some of you might could know exactly how many y's and where they go, but probably safer to say y to the negative 2 goes to the top, y to the negative 6 goes to the bottom, x to the 4th is still there. And now it's really easy to see, I think. What do we do with the y's now? Cancel, combine. How many y's are they going to end up with? And where are they going to be? And this is one of my all-time favorite wrong answers. You have to put a 1 up there. Like, it's not nothing. It's certainly not 0.
So you can't just put x4 over y4, or just x4 or y4.
Definitely not, because they're in the denominator. Okay, this worksheet looks terrible. We'll come back to it in a moment. Pass on that. Go to review of exponent properties, the next one. And I want you to try 1 through 8. Oops, put that where you can see it. So the next worksheet is that review of exponent properties. Try 1 through 8. All right, number 1. Perla, what's however many all that stuff is? What's that answer? 1, 2, 3, 4. It's 2 to the 4th. And 1, 2, 3, 4, 5, 6. Yes, I agree. Haven't done this worksheet yet, so checking on the fly here. Madison, number 2, what is the meaning of 4x cubed? B, so we got 3 4s and 3 x's. Yep. Adam, how about number 3? A to the 4th cubed is equivalent to B, because 4 times 3 is 12. You see, you maybe understand where the wrong answers are coming from, but it's not 4 cubed. It's not 4 plus 3. I guess that's 3 divided by 4, but come on. Lily, number 4, which is the same kind of thing? A, power to a power, we multiply. Carson, did you figure out how to cube 6 and x? I think so. 6 cubed and x cubed. Mustafa, same kind of question. What's 5n cubed? A. Natalia, you got 5y squared squared. What's that one equal to? That one's C. Good. And Braden, 2x cubed squared? C, 2x to the 6. Okay. Good deal on those. All right, let's rewind to today's worksheets. Or do we need to do 9 through 16? That's probably a good call. Let's do 9 through 16. So on that same worksheet, this is like the worksheets are out of order. This one's easier, so we're working through this one. Then we'll step up to today's worksheet. So try 9 through 16. They get a little bit harder.
Today's worksheet, dude.
So Brett, what'd you say number 9 is?
D.
D, because if I cube -2, I get -8. Power to a power, we multiply. So yes, D. Will, how about number 10?
C.
-27, y to the 15th. Yes, sir. Clara, number 11.
B.
3 to the 4th is 81. Power to a power, we multiply. So yes. Messam, how about a to the 5th, b to the 6th, all to the 5th?
B.
B, because we multiply both of those. Oh, thank you. Faith, similar to 13, what'd you get for, or similar to 12, what's 13? 4 times 3 is 12, 5 times 3 is 15. Yep. Lucas, number 14.
E.
4 times 2 is 8. N cubed, n squared is n to the 5th, so yes, B. Andre, number 15. 5 times 3 is 15. 2 plus 7 is 9, so yes. And then Liam, number 16. A. A lot of times we would rather 1 over y squared, but that wasn't an option, so yeah, A is fine. Well, I mean, I could not give you an answer choice where both of those were answer choices.
Well, obviously, but like, would you put the y equals -2 on the answers in the test, or would you put y?
It'd probably be this one, but it could be either one because they're equally correct.
The entire page together.
The entire page.
That's easy stuff. I want to do the hard stuff.
We're learning.
Let's back up and let's jump into the deep end of the pool here. Let's lock in, as the kids say. The students.
I know kids.
As the youngsters say, these young whippersnappers. Okay, looking at number 1. It's kind of crazy, but shh. All right, this is where we have options. On number 1, I don't want to pick somebody. So somebody volunteer. What would you want to do first on number 1? There's multiple options here. Andre? Hold on. Shh. Andre?
Put the 4 in the verse.
Okay, so Andre, you're saying distribute that 4 to everybody? Yes, that's fine. It's not the only thing you could do first, but it's okay to do first. Meso?
Could you cancel out the y's maybe? Like the y over 4 and the 2y over 4 to just make it 1 y over 4?
The 2's would still be there, but yes, you could cancel the y over 4's because they're going to cancel.
Right.
If you distribute the 4 first, that's fine too. You'll end up with y to the 16th and y to the 16th. and those would cancel. So either of those two options are okay.
Right.
So anybody got a preference? I think I have.
I think we should cancel.
I think we should cancel them first, because then it's a little bit easier. There's one less thing or two less things to deal with. Okay, there's still more to go, but let's distribute the 4 now. So 2 to the 4th, x to the negative 4, because power to a power we multiply, x to the 8, y to the negative 16, and be careful, be neat when you're canceling things, because there's still a 2 down there. 2 to the 4th. Okay.
1, 2, 4, and 2, cancel.
Again, there's multiple paths to go. Probably the easiest one thing to do first is 2 to the 4th and 2 to the 4th would cancel. What do we do with that x to the negative 4?
Bring it down.
You flip the
I'm going to flip that into the denominator.
Same as the y.
And what do I do with that y to the negative 16?
Bring it up.
Flip that into the top. Not quite done yet, because there's 2 x's in the bottom, so how many total x's are in the bottom? 12. So y to the 16 over x to the 12th. Okay, number 2 is similar. You can handle the negative 4 first, or you could simplify inside first. Although it's not as easy to simplify on that one. There's not an easy thing to cancel, so what would you like to do first on number 2? Do you want to clean up the inside, or do you want to distribute the negative 4?
clean up.
Clean up? Okay. You guys are picking opposite of first period. Clean up the inside. So when you say clean up the inside, that means we're not worried about the negative 4 yet. We'll get to that in a minute. When we clean it up, what do I mean by clean it up? What could I do to clean that up? How about the x's? How many x's are there going to be?
2.
Where?
On the top.
All right. That 2 doesn't have anybody to cancel with, so I can just go with the 2. Oh man, it's kind of early to do all of this at once, but some of you probably are doing just fine. Can you figure out how many total y's and where they'll be?
1 goes up.
2.
Goes down.
Y squared on the bottom. 2 on the bottom.
2 of them in the bottom.
Yep.
Does anybody not see how we get 2 in the denominator? Brett?
Can you just say like the ones on the top cancel?
You can, because you're adding. Yeah. So one way to get there is 1 plus negative 1 goes away,
Then you just leave the y squared.
and just leave the y squared in the bottom. What I imagine most people did, and maybe just because this is what I did, I see that y to the negative 1, I move it to the bottom. That puts 3 of them in the bottom, and 1 of them cancels, and I'm left with y squared in the bottom. But Brett, it's probably easier and better what you said, the y to the first, y to the negative 1, cancel, and that just leaves the y squared in the bottom. So again, there was at least 2 routes, even just to get the y squared in the bottom. A couple ways to go. Okay, I guess I like that you cleaned up the inside first, because now I just distribute the negative 4. And
Can we just like move?
I say there would come a time where some of you would not show that step, because you're going to multiply and flip. I'm showing my work for now. So where does 2 to the 4th go?
Bottom.
On the bottom. Speaking of showing your work, do we know what 2 to the 4th is?
16.
16. 16 in the bottom. X to the negative 8 goes to the bottom. Y to the negative 8 goes to the top. Let me show you what first period opted to do. Landed at the same spot, so you don't have to write this down. But someone said, can we just use the negative to flip the stuff, and that way we're done with the negative. So this was weird, but they used that negative, flipped the entire insides, left the 4 there because they only used the negative, then distributed the 4 to everybody, and then went about simplifying things. I don't know. It's different. Different than what we did. I don't know that it's weird, but it's different than what we did. So, more than one way to get there. Let's skip down to number 6. All right. Well, let's start picking on people now. We'll let Angel decide which route we take here. Angel, what would you like to do first on number 6?
I think we should cancel the ones.
I think we should. I think that's an obvious first step. We don't have to worry about the -3. Let's just cancel the y cubes. So yeah, there's a 1 in the top. Julian, what would you like to do next? I think there's at least 2 options, maybe 3 options.
Multiply the x squared into x cubed.
And what would you get if you did that?
2x.
Yes. All right, not much option left. Lucas, how do I handle that -3?
You get -1 on top. And then,
Wait, I'm raising each of these things to the -3.
right. Yeah. And then
So I'll flip the stuff. What is 1 cubed? 1, not -1. The negative flips it. It doesn't make it negative. Negative exponent flips it over. What's 2 cubed? 2 times 2 times 2. Uh-oh. Peyton, what's 2 cubed and where does it go?
It goes on top.
Good. So 8 in the top. X to the 15th in the top. And I will take off a point if you leave that as an answer, because that just looks silly. 8x to the 15th. You want to see what first period did, or not so much? Those crazy
No, not
first
really.
period people.
I don't think you really care.
Yeah.
So they canceled the y cubes first, because that was obvious. I was just sitting there like, let's get rid of those. And then they did the thing where they used the negative to flip it over. So they used the negative to flip it, and then they cubed everything. I think that method was probably better on number 6 than it was on number 2. More than one way to get there. All right, look at number 10. How glorious is that thing? Now we've got lots of different ways to go here. I see one obvious thing to do. Doesn't change a whole lot.
Y0 is 1.
Y to 0 is 1, so like, okay, thanks. Get rid of that. What would you like to do next? There's options here. Well, they're not plugging in anything. You say, like, use this -3, so distribute that -3 to everybody. That's an option. Any other options?
Distribute the 4 to the -3.
So the other option would be multiply the -3 and 4, because power to a power we multiply, and then we would distribute the -12.
So then,
So do you want to distribute the -3? And then the 4? Or do you want to do 3 times 4 is 12 and then distribute that?
3 times 4 and then do
I think so.
it.
So let's, -3 times 4 is 12. Oh, wait a minute, I need to be careful if I do that.
Yeah.
Why do I need to be careful?
Positive.
Because that x squared in the bottom will also need the 4. So I could do it, but what's the denominator going to be now? X to the 8th, because that 4 is going to that x squared as well. So x to the 8th and then all of this stuff to the negative 12. All right. You tell me, do you want to distribute the negative 12 or do you want to clean up the insides first?
Clean out the inside.
Okay. So I heard one of each. So I guess we'll take a vote here. Option A is to distribute the negative 12. Option B is to clean up the inside. So who wants to, option A, who wants to distribute the negative 12? Loud and proud. It's not wrong, it's just which do you prefer. So the two gentlemen in the back would like to distribute the negative 12. Who wants to clean up the inside first? Oh, you're outvoted, gentlemen. Okay, so cleaning up the inside. So I'm not worried about the negative 12 yet. Can't do anything with the 2. When I say clean up, how am I going to clean up the x's? What are those x's going to become?
2.
Squared. And when I say clean up the y's, it's going to be a y. And that's still to the negative 12, and it's still all over x to the 8th. Okay, now let's distribute the negative 12, because I don't know that we can do anything else at this point. What am I going to do with all those things that have a negative exponent? Flip them to the other side. What's going to be left in the top? 1. Yeah, don't leave it blank. 1 will be up there. 2 to the 12th. I'm running a little short on space here, so help me out. When I move the 24 x's to the bottom, how many total x's will I have down there?
32.
I'll move 24 of them down there. They'll join with the 8 and make 32 of them. Two to the 12. So when we get really big numbers, it's like, I don't really want to figure out 2 to the 12. I'll just leave it as 2 to the 12.
Do you care?
We're not going to give you numbers that are that big. So we'll probably say that we want you to find them all. So if you get like 5 cubed, if you don't have 5 cubed memorized, well then you just got to go figure out what 5 cubed is. And 2 to the 12 wouldn't be terrible because you just have to keep up with how many 2's you got.
2048.
I think it is 2048. Let's look at number 18. 18 is actually easier than it looks. 18.
It's 3x squared minus 5x minus 2. That's the final one.
Wait.
You can cancel out.
Okay.
You can knock.
What I heard, I don't want to give him credit because it was wrong, but what I heard was 3x squared minus 5x minus 1. Now I see where you got that.
That's wrong.
That's not right. Because that only divides the first term by x squared. Right? I got to divide all the terms by x squared. It's all over x squared. So it's like, well, the first term is right, but then the others aren't.
Oh, you just multiply everything by 3x squared.
Well, I would divide everything by x squared. Like that. So your first term was right, 3x to the 4th over x squared. That is 3x squared. What about the second term? What's that going to become?
5 over.
5 over x. And what about the last term? You can't do anything with that. 1 over x squared. So that was not hard, but like easy to mess up.
Dude, I thought of it.
Which I guess makes it hard. I don't know. Looking at number 20, what don't you like about number 20?
And the 1.
Yeah, fraction in a fraction. We don't like that. So I could clear that out. What would I need to multiply by to cancel that x? An x. But I can't just multiply the bottom by x. I'd also have to multiply the top by x. It's a little excessive. So what does the denominator become? 1. So I'm not going to write that because dividing by 1 doesn't do anything. So all I really got to do is distribute that x to the top. That looked ugly and turned into not be so bad of a deal. $22. Same. I'll try to get through everybody here. Everly, 22 has kind of the same issue as number 20, like a fraction in a fraction. So what would you like to multiply by that would cancel that x? X. But you got to do top and bottom. So this time the bottom's not going to go away. David, I'll put you on the spot. Can you multiply x to the top for us? Yep.
Minus 5x, 3, and minus 4x squared, and minus x.
Uh-huh. One more.
Oh, in the bottom?
No, still in the top. The x's cancel, but there's still
Plus x.
a minus 1. Now you're right, the bottom didn't go away on this one, so I do need to leave that, or include that. X times x would just be x squared. And then I guess I could do that. So it's unclear whether we would want this as an answer or divide each of the terms by x squared. I don't know which one is preferred.
Can we just give you that?
I'm okay with that.
Great.
I would be okay with that. I don't know what the answer key says. It went ahead and did one more step. Carter, put you on the spot. All 5 of them. Let's go. Let's divide them each by x squared. What do you get? I'm going to divide each of these terms by x squared. So the first one, x to the 4th over x squared, is x squared.
Okay.
What's the second term going to be?
5x plus 5x.
Yep. And then the next term?
Just 4.
Minus 4.
Yeah, minus 4.
And then now we start getting a little bit trickier maybe, but what's x over x squared?
Plus 1. Minus 1.
Well, the minus 1, but what's x over x squared?
Minus 1
Over x squared. One of the x's will cancel. And then the last term, I can't really do anything with. 1 over x squared. And that would be my final answer. Yeah. Okay, flip back to the front. I'm only assigning the odds for now.
Yeah, you should assign evens.
Yeah, assign evens. Why would you do that?
Cruel, 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 aren't I? Yeah. Do you want to do number 3 together then, just because that was mean?
No, number 5.
Number 3. What do you want to do first on number 3? I would do this thing. They did. You can wait. You'll be all right. So m squared n to the negative 4
He said it because he wants me to stay back for this, actually.
over M4 N4. Some of you are going to jump straight from here to the final answer because you're going to keep track of all the N's and write it down, and then keep track of all the M's and write it down. Good luck. Be careful. I'm going to slow down and I'm going to move that into the -4 to the bottom. Let's see here. Into the -4. Puts that into the 4th in the denominator.
And to the 8.
Then I think I'm ready to skip to the end. I can handle all the N's at once here. That is into the 8th in the bottom, but there's one in the top.
So you gotta go end to the 7th.
So into the 7th in the bottom.
N to the 2.
And then M to the 2.
And 1 of
That's right, again. That's all-time favorite answer right there. The blank over N squared, or N7M2. You need a 1 up there.
So would you take, like, would the entire answer be wrong, or would it be like, would you just take 1 point off?
No, there's definitely partial credit on these, because if I can see that you got the M's right, but you messed up the N's.
Right, but if you just completely, like, forgot the 1, you draw the line and you just leave it blank.
Oh, if you did leave that blank?
No, yeah, if you just draw the line, would you take off?
I would take off something. Not everything, but certainly something.
the order of the letters on the bottom.
Yeah, that's a good question. It does not. So, like, if you were working it and you got things, I don't even say shuffled around, but you ended up with M first, that's fine.
Who left the restaurant?
George.
Who's that?
Okay, so your assignment is the odds. This is not due Friday. This is not due until after the break. Hold on. But you do have a chunk of stuff due on Friday, so you might want to spend some time working on that. Up to you.
Just go to the back.